Hi everyone. Today in this video I am going to teach you what is scope, what do you mean by scope rules, and what do you mean by static scope rules. First we look what is scope. Names are bound to various elements of a program. Okay? Names are bound to various elements of a program. What do you mean by the scope of a name? Scope of a name n means all places in the program where n denotes the same object. What do you mean by a scope of a name? Denotes all places in the program where n denotes the same object. Then another is scope of a variable is there. It is a range of statements in which the variable is visible. Wherever the variable, which are the statements in the program, that variable is visible, that is the scope of a variable. Then a variable is visible in a statement if it can be referenced in that statement. There are two types of variables, local variable and non-local variable. What do you mean by local variable? The term itself denotes that local variable is local in a program unit or block if it is declared there. Okay? A non-local variable means it is outside. Non-local variable of a program unit or block are those that are visible within the program until or block but are not declared there. So, scope rules of a language is there. It determines how a particular occurrence of a name is associated with a variable. Okay, how a name is associated with a variable. So, scope rules of a it depends upon the language. How a particular occurrence of a name is associated with a variable. So, you remember these points. What do you mean by scope of a name? It means that scope of a name n means that all places in the program where n denotes the same object. And scope of a variable means the range of statements in which variable is visible. And scope rules of a language determine how a particular occurrence of a name is associated with a variable. Here is the example of a scope denoting. Here is a program segment. Main int a equal to 0, b equal to 0, beginning of b0, block b0. Then int is equal to b1, we can see it is represented in orange color. It is beginning of b1. Then block b2 is there. Block b3 is there. Just go through the program. Here we can see scope of b0, b1, b3 is there. Then in second range statement, scope of b0 is there. In next statement, we can see scope of b1 and b2 is there. Int a is equal to 2, we can see that is scope of b2, and we can see scope of b3. It represents where is the range of statements where this variable is visible. Then we go to different types of scoping. There are two types of scoping, static scoping and dynamic scoping. So what do you mean by term static scoping? Static means before runtime we will decide everything that we studied in last video. It allows us to determine the use of every variable in a program statically without executing it at compile time. So before compile time, the use of every variable in a program is determined. That is static scoping. In static scope rules, the bindings are defined by the physical structure of the program. So static scope rules is determined when it is defined by the physical structure of the program and determine the use of every variable in the program without executing it at compile time. Then another is dynamic binding. With the dynamic binding, bindings depend on the current state of the program execution. Bindings depend on the current state of program execution. The idea is to search for a name in a chain of called procedures. Starting from the main program, this chain is built according to the visibility rules. So you remember what is static scoping and what is dynamic scoping. Okay, static means before the use of variable is determined without executing at compile time, and dynamic scoping, it depends upon the current state of program execution. So first we study what is static scope rules. In a language with a static scoping, the bindings between names and objects are determined at compile time by examining the test of the program without consideration of the flow of control at runtime. The simplest static rule is probably that of early versions of BASIC. And scope rules are somewhat more complex in Fortran, like pre-Fortran 90. So static scope rules is that the static scope rules, it is determined at compile time. To connect a name reference to a variable, the compiler must first find the declaration. Okay, when a name reference is to a variable, what is the first process is that the compiler must find the declaration where it is declared. So first search process is there. Here in this first they search declaration first locally, then in increasingly larger enclosing scopes until one is found for the given name. Enclosing static scopes are called static ancestors. The nearest static ancestor is called static parent. This is a static scope rule. Whenever we have to connect a name reference to a variable, we have to first search locally. If it is not there, we will go to the outer loops until until one is found for the given name. For example, suppose a reference is made to a variable x in subprogram sub1. The correct declaration is found by searching the declaration in subprogram sub1. If no declaration is found for the variable x there, then search continues in the declaration of the subprogram that declared subprogram sub1, which is called static parent. If declaration of x is not found there, then search continues to the next loop. Okay, until a declaration of x is found. If no declaration, if no error, if nothing is found, an undeclared variable error has been detected. The static parent of subprogram sub1 is called the static parent, and so forth up to and including the main program are called static ancestors of sub1. Just remember, there is a variable x is declared, a reference is made to variable x in a program sub1. Then what is doing? We will look, the correct declaration is found by searching the declaration in subprogram sub1. If it is not found, we are going to the outer loops until a declaration is found. If nothing is found, an undeclared variable error is declared. This is static scope rule. You will get more clear this example. Here you can see procedure big. X is declared there, x integer, okay. Then another procedure sub1 is there, procedure sub2 is there, okay. So first we say procedure sub1, we will find x is there. Where is the declaration? Is there any declaration in procedure sub1? No. Then what happens? The control goes to outer loop, which is the outer means static parent of sub1. Who is the static parent of sub1? That is big. You can see declaration of x there. So the search ends there, okay. So that is the static scope rule. In procedure sub1, x is there, but x is not declared there. So we will find where x is declared. So the next step is what? We are going to the static parent of sub1, that is big, where the x is declared. We can see the x integer that is declared in procedure big. So the search ends there. This is the static scope rule. In another program, you can see void sub is there, int count, while int count plus. In sub, you can use count. That count is hidden in the while loop. In void sub, you see a count. That count is what? It is hidden in the while loop. So, some languages allow the programmer to access the occurrence of a name by applying a qualifier or scope resolution operator. That is, in some languages, we can see the hidden part. How? By applying a qualifier or scope resolution operator. The count of sub is hidden from the code inside the while loop. A declaration for a variable effectively hides any declaration of variable with the same name in a larger enclosing scope. So in C++ and ADA allows access to these hidden variables. So in ADA we can use main.x In C++, class name scope resolution operator name is given. So you can access that hidden values. The reference to a count in the while loop is to that loop's local count. This is all about static scope rules. I will come with the next video. Till then, bye.